So this is my annual Vlado in Renderland talk that I do for a few years in a row now. We are going to go through various related news. We're going to have a live demo at the end. And I haven't done live demos since we last showed V-Ray GPU 10 years ago. So again, we'll be showing GPU live demos this time. So fingers crossed, things will work. If you're here, you know what V-Ray is. We've been developing ray tracers and rendering technologies for 20 years. V-Ray is integrated into a number of applications, and this number grows a little bit over the time. And we'll talk about some of our new products this year. What we do, we solve hard problems for you, which also means that if you have problems that need solving, we can help. Starting directly with V-Ray Next for 3ds Max. I'll just go briefly over this. V-Ray Next for Max was released earlier this year at Total Chaos in May. It's our version of V-Ray after 3. It's called V-Ray Next. Why it's not V-Ray 4? Because when you say V-Ray 4 for 3ds Max, it becomes a little bit hard to pronounce. And also, we realized that in some places, the number 4 is unlucky. So that's why it's V-Ray Next. It has a bunch of new features, and you're probably all familiar with them. We've optimized V-Ray a lot. It's a lot faster and takes advantage of newer CPUs. V-Ray GPU is twice as fast. It has a new hair material and a lot of other cool new features. But in coming up updates, we will also be adding more stuff. One of the things that we want to add is color management workflows in V-Ray. Specifically support for ACCG. For those that don't know what this is, ACCG is a color space that is defined by the Motion Picture Association of Association of Motion Picture Arts and Sciences, and it's designed to be a standard color space for film work. It defines the way colors should be represented in textures, in the final rendered output, and in compositing. And it's different from the sRGB color space that is widely used now. ACCG is a bit wider color space, so it can represent more colors. And it's becoming rapidly the standard workflow in VFX. And V-Ray needs to support this. In the existing versions of V-Ray, you can do an ACCG workflow if you use something like the V-Ray OpenColor.io texture to convert input colors and textures to the right color space. But it's a clunky workflow, and it's not really very pleasant to work with. So that's why we've added this capability directly into V-Ray. So what this means is that V-Ray HDRI in 3ds Max can recognize the correct color space of a texture by looking at the file name. So if you put ACCG somewhere in the file name, it will know that this texture is an ACCG color space, and will do automatically the right conversion. And you could also, if you want to manually, you can override the color space of a texture. And this makes mixing textures with different color spaces a lot easier. Obviously, it relies on you, on the user having to name the textures in the right way. But like I said, there's a manual override if you need it to. Also, in V-Ray color textures, which is basically a color swatch, you can specify what the RGB values mean. They can be sRGB values, they can be ACCG values, and you can control that. Also, V-Ray has, in a few places, spectral calculations, specifically when it deals with the V-Ray sun, the V-Ray sky, and also dispersion. And now we have made these calculations aware of the color space of the renderer. So you can tell V-Ray that it's rendering in ACCG, and it will automatically convert all the temperature colors and lights, for example, to the right colors for the particular rendering. So hopefully this will make the workflow a lot easier if you need to do that. We've improved the IPR in 3ds Max. The light cache preview is basically used as a rough, lower resolution preview of the scene, so it should look a lot nicer. Also, there is a new frame buffer that we've been working on for a while. I know that we've been talking about the new frame buffer for a long time. And just it turned out that the developer who worked on the frame buffer also worked on the new GPU demo that I will be showing Lavina later on. So if the frame buffer is a little bit behind schedule, it's because of that. Just so you know. We've also extended the V-Ray Cloud Submitter for 3ds Max when we have a button to submit scenes to the V-Ray Cloud. And the way this works in 3ds Max is a little bit different from all other integrations because in Maya and SketchUp and Rhino and everywhere else, and Houdini also, what you see with V-Ray in the application is what gets rendered on the cloud exactly. With 3ds Max, it's not exactly the same because we have to convert the scene to a V-Ray scene and send it to the cloud to be rendered on Linux with V-Ray standalone, actually through the app SDK. So there is a conversion that happens, and sometimes things may get lost, like some third-party plugins that we don't recognize. We do try to support most of the important 3ds Max plugins for the cloud. So we support Forest Pack, Multiscatter, or Nitrix, Air Farm. All those plugins work fine with V-Ray Cloud, but there are a few things that don't. So we tell you what works and what doesn't. And this is also helpful if, for whatever reason, you just want to export the V-Ray scene file to render with the V-Ray standalone. Then we tell you which parts of the scene will not translate exactly, so you can make decisions based on that. Finally, the V-Ray instancer is optimized quite a bit, so it should be faster if you do millions of instances. We do have to some additional work to minimize memory usage for instances, but this will also be done in time for the next update. And many other new things that will be obvious as we get closer to the first update. V-Ray for Houdini is already released as a public beta this time. So it's been around for, I don't know, maybe 2 years now on GitHub as an open source project. But we decided to make it an official Chaos product. So it has an official download, it has a forum section, nightly build support, and everything that you expect from all of our other products. And like I said, it's been around for a while, so we've had time to implement the most important features that users wanted from V-Ray for Houdini. And we should be able to use quite a lot of the native Houdini features with V-Ray. Also, you can export V-Ray scene files to bring into other applications. You can export V-Ray mesh files as proxies, and you can also bring them in. All these workflows that you have in other applications work fine with V-Ray for Houdini. It's right now, during the beta, totally free, so you can go and download it and play with it, and we would appreciate any kind of feedback on our forum. For Maya, Beta 2 for V-Ray Next was just released a couple of weeks ago. We have one more beta 3 before the official release. And a few more features will get in. The release will be done hopefully somewhere in the fall, September or October. We'll see how things go. The main highlights are, it's obviously V-Ray Next, the V-Ray Next architecture. So it has the V-Ray Next SDK, which means that custom plugins for V-Ray will need to be slightly reworked, hopefully not too much. But due to that rework and due to the optimization that we've been doing, V-Ray Next should render a lot faster. And we've had some very good feedback from customers on the performance improvements. IPR is totally rewritten and is a lot more responsive than what we had in V-Ray 3.6. And we'll see in a moment in a video. We have a new toon shader, which is a combination of a cell shader that you apply to the objects as material. And also we have worked to extend the V-Ray toon outline shaders to be a little more controllable. We've done some research on light path expressions. This is working already in internal builds, but I'm not sure if it will go into the first official release, but it's moving along. We also added specialized UI for V-Ray GPU. One of the main problems that we had with V-Ray GPU is that we have a lot of options in V-Ray, and not all of them are supported in V-Ray GPU because they were outdated or didn't really make sense in a GPU rendering situation, but users didn't really have any guide to that. So we made sure that now when you select GPU rendering in Maya, you only see options that are actually supported on the GPU. And in this way, it's a lot easier to build scenes that will render fine with V-Ray GPU. Because what we found, the workflow of most people will be to build their scene with the regular V-Ray, having all the options and all the stuff that we have there, and try to, in the middle of the project, try to render it with the GPU. And that often doesn't work too well. So that's why we made it easier for people to recognize what would work on the GPU and what won't. We've extended the V-Ray material to have a new metalness parameter for PBR workflows. There's also an option to switch between glossiness and roughness. And hopefully this should make material exchange with other applications like Substance Designer a lot easier. There's a new physical hair shader. You saw that some of that on the image of one of the images for V-Ray for Houdini. It's based on a paper by, I think it was Disney, for scattering hair from fibers. But we also did some research to add glints and glitter effects to the shader. And this is original research and took a lot of time to get right. But it's also in V-Ray for Maya right now. We have the adaptive dome lights, which can help lighting complicated interior setups. So they remove the need for light portals in many cases. And we've also integrated the NVIDIA AI denoiser. And we'll show this in a video a bit later on. The denoiser is good for interactive feedback because it's very fast. So it helps you to see beyond the noise very quickly. It's not designed for final renders because it's not really temporally stable. So if you use it for animations, it will tend to flicker a little bit. For animations, you still have to use the V-Ray denoiser. But for IPR, there is the NVIDIA one. Other things that we have to add before the release is memory reporting. It's one of the most wanted features in V-Ray for Maya. Basically, when you render something and it takes a lot of RAM, you need to know where that RAM goes. And we should be able to tell you which object or which texture takes the most memory. Also, debug shading, especially useful during IPR when you want to isolate components of a shader and see just a specific texture. And IPR-based play blast was also, especially with the GPU, was a very requested feature. So that's coming as well. This is a video that we did to compare the IPR workflow between V-Ray 3.6 and V-Ray Next. So what we're doing basically just moving the camera around the scene. And you can see that V-Ray Next responds to camera movements immediately and is very smooth, whereas with V-Ray 3.6, we only updated the camera when you release the mouse, and also the updates are not as smooth. So doing IPR with 3.6 was a little bit harder. Hopefully you should get a lot better now. And this is not a GPU render, this is just a regular CPU rendering. So it's still pretty fast. This is another IPR video, this time using the NVIDIA denoiser. This one is a GPU render. So the previous one was CPU, but this one is GPU. And you can see that you can get a clean result really, really quickly. This is the denoiser is in the current beta that's on the website is just working in the V-Ray frame buffer, but we will add it to the viewport IPR mode for V-Ray, so we should be able to get this denoiser also in the Maya viewport. Some images of the toon shader. There's a nice turntable. And also a longer video that also shows the toon shader working with V-Ray IPR. All right. Cloud rendering. Also another big announcement for us at SIGGRAPH. V-Ray Cloud is in open beta right now, which means that basically you get free rendering with V-Ray through the V-Ray Cloud as of today. So you can go to our website, you can register, and you can start rendering with V-Ray. Almost all our applications now support rendering to the cloud. This includes V-Ray for Max, V-Ray for Maya, SketchUp, Rhino, Houdini. You can also submit directly V-Ray scene files from a command line-based submitter. So render everything that you want. And the way that it works is it's a really simple workflow. This shows it in 3ds Max. So this is a scene that we'll see later on running just a little bit faster. But this is the regular V-Ray in 3ds Max. It's quite a high resolution image. It's something like 4,000 by 3,000. So it takes a while to render on this i7 workstation in our office. But we have a cloud button that allows you to send this to the V-Ray cloud. And you upload the scene, specify the resolution, and submit the render. And you get the final result. This is not quite real time, so the actual render took 9 minutes, but still pretty impressive. And once the render is done, you can download the file, get a JPEG and an OpenEXR, and work with that. This is quite a big scene. It has, by last count, 120,000 instances. I know that in other places I said 80,000, but I forgot that there are actually two V-Ray instancers in the scene, so it's a little bit more. It's 100 million unique triangles, and the overall number of polygons is 300 billion triangles. So that's the way you render on the V-Ray cloud. Obviously, it can render not only still images, it can render animations as well. But the main goal for us was to make this cloud system as easy as possible. There is no complicated setup of virtual machines or accounts or anywhere. You just use your regular Chaos Group account. And when you register for the beta, we give you a certain amount of cloud credits. And once you run out of credits, you can request more. So we encourage you to do that. It's also pretty fast. It renders on the Google Cloud, and in the time that you render one frame, you can actually render an entire animation. It's pretty impressive. We also upload assets in a very intelligent way. We only upload changes from the previous state of your scene. So if you upload something like a V-Ray proxy or texture, once it will remain in your project on the cloud, and if you resubmit the same scene with only slight modifications, we will transfer just those modifications. And this goes not only for assets, it's not only textures and proxies, but it's also the scene itself. We will only, if you just move the camera, we will only transfer this new camera position to the cloud. We won't upload everything again. We also keep the data on the cloud in a smart way. It's specific to you. It's encrypted, so nobody else can see your data and your assets. But we also attempt to keep one copy of all the assets. So if you use the same texture over and over again, we just store one copy of it. You can also track the progress of your jobs on V-Ray Cloud from anywhere, through any browser. It can be your phone, your tablet, or your PC. You can cancel jobs. You can resubmit a job with different parameters. For example, you can override the resolution to make a quick preview of your project, or you can fire up a higher resolution final render, and you can do this from your phone, so it's super easy. It's running on the Google Cloud, which means that upload and download is fast no matter where you are in the world. And we found that this is very important for our customers. It's also secure. the Google Cloud has been certified by the MPAA, and nobody else can see your data. That's important. Here is a quote from one of our users who tried the beta version. Basically, for the time that you get to render one frame on your local machine, you can get the whole animation rendered on the cloud. It's very convenient. It was for me, at least. It's in public beta. You sign up with your regular Chaos Group account. You get free credits. If you run out of credits, you can request more. We have a forum for it, and any feedback about this is completely welcome. One also important thing that is not here, but I think it's important, we also track the version of V-Ray that was used to export your project, so we make sure to render with the same V-Ray version on the cloud. So there is no, like if you render with V-Ray 3.6 or V-Ray Next, we make sure we render with a matching version of V-Ray, so there are no issues or discrepancies. So it renders exactly as it does on your local machine. Moving on to other ways to accelerate rendering beyond the cloud, V-Ray GPU is now faster than ever. We rewrote the whole architecture this year. At GTC, we released the first results, and V-Ray GPU is basically twice as fast compared to what we had in V-Ray 3.6. It also supports new features like the new physical hair material. It also supports volumetric rendering, specifically OpenVDB grids and the environment fog. It supports tags in bitmap file names, and the new Maya lookdev utility nodes, and many other things. And for the official release of V-Ray for Maya, we hope to have a few more features in V-Ray GPU. The first of them is bucket rendering, which is a weird one. I thought that we were moving away from buckets, but apparently that's not the case. So what this will give us, first, bucket rendering for the GPU will give us support for cryptil mats and deep output. Cryptil mats are, for those of you that might not be familiar with them, an easy way to extract masks from a render for various objects or materials without adding multi-mat render elements all over the place. We've had customers that add hundreds of multi-mat render elements to their scenes just so that they can isolate different objects. And this was very inefficient, both from RAM usage perspective and from CPU or GPU cycles perspective. So cryptil mats are an easy way to get any mask that you want with just very few resources. And now this is supported by V-Ray GPU as well. In addition to that, we're working on supporting the AL surface material. We have supported subsurface scattering in V-Ray GPU for a while, but only for the original V-Ray fast SSS material. Now AL surface works as well, including the subsurface scattering, obviously. Out-of-core textures and geometry are also on the roadmap. Right now in V-Ray GPU, we have something that's called on-demand textures, and it works pretty well by loading only those textures that are needed for your scene and for the particular view of a scene. It can reduce memory usage for textures quite a bit, but it's only on demand. It's not out of core. Like, it will keep loading but never remove textures from GPU memory. And this is the second part that we're completing right now, being able to render with just a limited amount of textures. And later on, we'll port the same concept to rendering with geometry so that you can render very large scenes with V-Ray GPU. Also, over the past few months, we have been working with NVIDIA to support their new RTX technology. If you have seen NVIDIA's announcements on Monday, you know that the new Turing cards have these new cores called RT cores, which are specifically designed to accelerate ray tracing. And they actually do a pretty good job of that. They accelerate specifically ray casting, which is just taking a ray and intersecting with all the objects in the scene, which is one part of the rendering process. Depending on the scene, it can be a significant part. So we have estimated that somewhere between 20 and 80% of all rendering, depending on the scene and the shading complexity and the scene complexity, is spent on ray tracing, so which means that you can get quite a speed boost for some scenes. And let's see some of those things in action. So this is a V-Ray GPU render. We're using bucket rendering for this. So this was done on quite an old GPU. It was a Quadro M6000, I believe, because this is what the 3D artist who recorded the video had in his machine. So V-Ray GPU supports quite a few generations of GPUs, so it can work on the brand new cards, but it can also work on older cards. And actually, V-Ray GPU is a little bit special compared to other GPU renders in that it can also work with future GPU cards, which means that if you get a new Turing card right away, V-Ray GPU will work with it. It will not use the new RT cores, but it will still work just fine. You don't need a new version of V-Ray. And this goes back to V-Ray 3 as well. So we have 6 buckets here, but it's actually just one GPU. It's not 6 GPUs. I know that other GPU renders show you 1 bucket per GPU. We don't do that. We add 6 buckets per GPU just because it's better for getting the most out of the GPU. We keep it busy and we give it more work, so the end result goes faster. In this scene also we have a CryptoMat render element that is based on object IDs, and you can see that it comes out just fine. The buckets, when we do GPU rendering, we increase the size of the buckets a little bit because we try to give more work to the GPU. Having a small bucket size is not very efficient from what we've seen, so we try to keep the GPU busy as much as possible. And this whole render generally takes about 2 minutes. So let's skip directly to the end. It's quite a heavy scene that we did for one of the V-Ray Service Pack releases, so there's quite a lot of geometry. And you can see all the different CryptoMat layers were calculated. And this other part is in Nuke. For those of you that are not familiar with CryptoMats and the way that they work, once this is rendered, once you get the OpenEXR file out of V-Ray, you can bring it into Nuke, and then using the CryptoMat plugin for Nuke, you can extract masks for pretty much any object in the scene just by clicking it. And you can do this separation based on objects or materials, or you can also do it by the full name, like you can do a full hierarchy selection in Nuke, and it can be super helpful. The next video is showing V-Ray GPU running with NVIDIA's RTX technology, and you'll have to trust me that this is what it does, because you can't really tell. It's just V-Ray GPU, and it works just like regular V-Ray GPU, but faster. So this is running on one of the newer experimental NVIDIA cards. This was done a while back, so it's one of the early experiments that we did to get this technology working. It supports everything that V-Ray GPU normally supports, and also it helps with geometry updates. The optics API that we use for this right now deals with changing geometry in the scene a little bit more efficient than what we had in V-Ray GPU. So this is also a bonus for us. And the other bonus is that optics uses a little bit less GPU memory than our original GPU code. So this allows it to render even larger scenes on the GPU. Right. So we don't know yet when a version of V-Ray GPU with RTX support will be coming out, because it's not easy to rework V-Ray GPU for this. It basically requires us to turn it yet again upside down. You know that V-Ray GPU originally supported OpenCL, and then supported CUDA, then supported CPUs, and now we have to support RTX. So this code has suffered a lot. That's what I can tell you. But it still runs fine, which is amazing. I think that our GPU guys did an amazing job of writing code that can be so general that it can be easily repurposed to work in all these different situations. And for RTX, we really want to make sure that we get the most out of the hardware. So we want to spend some time to optimize it properly for that. It's a completely new hardware. It's not exactly the same as what we had in CUDA before. So it's a little bit of trial and error, but hopefully we'll get there. V-Ray for Unreal is yet another way to get faster renders out of V-Ray. We are getting closer to beta 2. We released the first beta in the spring. What's new this time is light baking, foliage support for scattering stuff inside Unreal, support for V-Ray proxies, proper support for V-Ray proxies, meaning that you get the low resolution preview of the proxy in Unreal, and then you get a high resolution version of the geometry in the V-Ray render. We also added progressive rendering, the same that we have in all other integrations of V-Ray. And we also added support for native Unreal materials. In the first beta, we could render a very basic version of those materials. We expected that people would bring in V-Ray scene files from other applications, and in that case, they would deal with V-Ray materials. But it turned out that a lot of people actually do create stuff in Unreal directly, and they want to render it with V-Ray. So we had to give them a way to do that, and we support those materials. So in this video here, what we did is take a bunch of V-Ray proxies. We scattered them around, and you can see the lower resolution version of the proxies in the Unreal viewport. But when you do the actual render, you get the full geometry. And then what we can do is we can add some grass to the ground. And then we can scatter some rocks around. And Unreal has really nice tools to create these landscapes, so it can be very convenient to do that in Unreal. And the cool thing is that you can export this as a V-Ray scene file, and you can bring the same V-Ray scene file in 3ds Max or Maya and render it with the rest of your scene. This video is about texture baking. And so this is a V-Ray scene file from 3ds Max, imported from 3ds Max by Bertrand Benoit. And we go to V-Ray, we select Bake, and sometime later, you get a baked light map out of V-Ray for Unreal. It can take a little bit of time to do the whole baking stuff. It's not exactly as fast as you see in the video, unfortunately. But what you get is a preview of the rendering in the scene. And it's actually exactly the same as what you would get if you do a real V-Ray render. So you can see that the live IPR rendering and the Unreal result match pretty closely. So you can be certain that the lighting that you get from Unreal is exactly the same as what you had in your original V-Ray scene file. And at some point, we will want to send the baking to the V-Ray cloud. So basically, when you press the bake button, your scene will be packaged, sent to the cloud. The light maps will be computed there and downloaded to you. So you don't have to wait too long to get this type of result with Unreal. So that will be pretty cool. We don't have it just yet, but it will be there. All right, and the last Unreal images of rendering native Unreal materials with V-Ray. So this is what we support right now, and it mostly works fine. Obviously, there's a little bit more work to be done on some of the materials, but the results match pretty closely. And we get to the interesting part, just in time. We announced on Monday a new project called Project Lavina, which is a real-time ray tracing technology that we did. It's basically a research project. We wanted to see how far we can push the RTX technology from NVIDIA and to see what are the capabilities and what are the limitations. So what you see is simply an experiment. We don't pretend that it's yet a final product. Our goal was to make a real-time preview of a V-Ray scene file based on DXR with pure ray tracing. So we didn't want any pre-calculation. We didn't want baking of light maps. We didn't want unwrapping of UVs. We don't want people to have to place reflection probes, which you have to do if you go to a game engine like Unreal. And it's fine because you get very good results, but it's a lot of work. And we have customers that just want to click a button and get to an interactive situation where they can walk around the model and look at it from different sides without bothering with the technical details. And the other requirement that we wanted to do was to build this for very large data sets. And we specifically researched how to do out-of-core geometry ray tracing with DirectX and with the RTX technology. This is the implementation. The first implementation is an interactive V-Ray scene viewer that we implemented to test it out. And here is the part where we do the live demo. So fingers crossed. It might take a while. So when this gets running, it will take a while. So now you can drag and drop any V-Ray scene file into the V-Ray scene viewer. And this is the exact same scene that we saw rendered with the V-Ray cloud earlier. So it's got a bunch of V-Ray proxies in it. To be precise, there are like 20 VR mesh files. But they're scattered around. So there are two V-Ray instances in the scene. It was exported from 3ds Max. One of them has 40,000 objects. The other one has 80,000 objects. So its total is 120,000 instances. If you count the unique number of triangles, there are 100 million. When you combine all the instances, it's more than 300 billion triangles. And this is kind of what it looks like. We also have a few camera animations that we exported from 3ds Max. So this is what you get. And this is obviously not pre-recorded. It's real time. So what I can do is I can pause this and then controls are a little bit iffy right now. But you can look around and you can zoom into stuff. We actually, when we posted the video on YouTube, somebody said, "How do I know that these are not just billboards of the trees?" And you can see that they're not billboards. There's also no opacity mapping. Everything is pure geometry. Every single leaf is modeled, so this is not it's not a trick. The only texture map here is for the landscape and also for the environment. We're also using heavily denoising for this. Even though RTX gives us the ability to trace rays very quickly, we can still only do just a few rays per pixel, whereas a final image from V-Ray can take thousands of rays per pixel to compute. So we're not there yet with real time, so we have to use denoising quite a bit to get there. But still, it's better than nothing. So if we look around, we can actually see that there's a house right here on the edge of the lake. Originally, we thought that we should make a nice fly through around the house. But then it turned out that the model of the house that we have is slightly above the ground, so we didn't look so good. Just one end of it is just flying a little bit in the air. We can pull and zoom again. See what it looks like. We also supported, in addition to camera animations, we also support animated transforms with this. We haven't looked into deforming geometry yet, but it is also possible to do that. So there are a few other examples that we have for this. And it's pretty much drag and drop V-Ray scene files from, in this case, they were exported from 3ds Max, but obviously they could come in from anywhere. I didn't really do anything much to the V-Ray scene files. There's no specific preparation that needs to be done inside of Max. You just, let's get this out of the way. Advanced capture. Okay, there we go. And you can walk around and it looks like a game basically, but you can also see reflections a little bit, and also they're not screen-based reflections. Obviously, I can see what's behind me reflected in the mirror just fine. The current implementation does, this specific implementation obviously does a sunlight and also one bounce of GI. We do reflections and refractions. We can do texture maps, but in a real-time situation, we can't really do a lot of procedural shading. So it's not very realistic to expect to bring in a full production shading network in this and still run at 40, 30 frames per second. It will still do maybe like 5 frames per second, but if you want the frame rate, you have to keep the shaders relatively simple. That's what we found. Let's see a few other scenes. And you can see that the millions here go up quite easily because just when people build scenes in Max, they don't think so much about actually going to real time. So bringing in millions of polygons is not really a problem for Lavina and for DXR. Again, this scene is relatively, so the HDR is weird, don't pay attention to it. This ship is not supposed to be there. But it just looked nice. And so we can do GI. In this case, it's a little bit dark because we only do one bounce. We can do more, but it loses the interactivity at this moment. You can also see through the glass. The denoising makes it a little blurry. It's not perfect. And I myself don't like denoising too much, but in this case, with only a few rays per pixel, there is really not a whole lot that we can do. We need the denoising, and we hope that it can be made to work better. So at some point, we will probably try to find out ways to make it look nicer. What else can we do? There's one more scene that I wanted to show you. This one is an office space. There's some coffee machine here. And like I said, there's no light baking. Everything here is calculated completely in real time. Yeah, this scene worked fine. Some scenes work better than others, so it's still real time. So there's still limitations that you have to consider, but still a lot better than waiting minutes for a render to complete. And that's it. Cool.